Okay, we have two wave functions, x1 of t and x2 of t. x1 of t is 5 times sine 100t plus 30 degrees, and x2 of t is 20 times sine 200t plus 45 degrees. The first question is to write down the amplitude of the waves, the angular frequency omega, the frequency f, and the initial phase phi 0. The second question is to use compound angle identities and separate waves into distinct component waves. And the third question is to find what is the sum of x1 of t plus x2 of t. So for my number 1, I'm writing down my waves. x1 of t equals 5 times sine 100t plus 30 degrees, and x2 of t 20 sine 200t plus 45 degrees. We have too much, so in general form is x of t equals capital A sine omega t plus phi 0, and we have that x1 of t is 5 sine 100t plus 30 degrees. So from here we obtain that the amplitude is 5, omega is 100 rads per second. We know that omega equals 2 times pi times f. F equals omega over 2 pi. So it's 100 over 2 pi hertz. And that is 50 over pi hertz. That's my frequency f. And then to find the initial phase, you put t equals 0. So my initial phase phi 0 is equal to 30 degrees. So what we have, A equals 5, omega equals 100 rad per second, phi equals 50 over pi hertz, and phi 0 equals 30 degrees. And the other signal is x2 of t. x2 of t equals 20 sine 200t plus 45 degrees. And the general form is a sine omega t plus phi 0. So from here, the amplitude A equals 20, omega equals 200 rad per second, phi equals 2 pi f equals omega. So from here, phi equals omega over 2 pi. Omega is 200 over 2 pi. So that is 100 over pi hertz. And for t equals 0, the initial phase phi 0 equals 45 degrees. Question number 2, we want to use compound angle identities to separate waves into distinct components. So we have that x1 of t equals 5 sine 100t plus 30. We use the identity that sine A plus B equals sine A cos B plus cos A sine B. So my x1 of t becomes 5 sine 100t plus 30 equals 5 times sine 100t cos 30 degrees plus cos 100t sine 30 degrees. Cos 30 degrees is square root of 3 over 2 plus the sine of 30 degrees is a half times cos 100t. So x1 of t can be written as 5 over 2 square root of 3 sine 100t plus 5 over 2 times cos 100t. So I have split it into two component waves, that one and that one. I do a similar thing for x2. What is my function x2? 20 sine 200t plus 45. So that's 20 times sine 200t cos 45 degrees plus cos 200t sine 45 degrees. Cos 45 degrees is square root of 2 over 2 plus cos 200t sine 45 degrees is square root of 2 over 2. So I have 20 times square root of 2 over 2 sine 200t plus 20 square root of 2 over 2 cos 200t. So what I get at the end of the day is 10 square root of 2 sine 200t plus 10 square root of 2 cos 200t. So I have broken my signal into two wave components, that one and that one. And the last question is to find the sum x equals x1 of t plus x2 of t. X of t equals x1 of t plus x2 of t. X of t equals, so my x1 of t, I can substitute that formula, 5 square root of 3 over 2 times sine 100t plus 5 over 2 cos 100t plus the x2, which is 10 square root of 2 sine 200 times t plus 10 square root of 2 cos 200t. So I have 4 distinct components there. I can rewrite it more clearly, 5 square root of 3 over 2 sine 100t plus 5 over 2 cos 100t plus 10 square root of 2 sine 200t plus 10 square root of 2 cos 200t. And that is my final answer. I have 4 component waves, 1, 2, 3, 4.